Let's see. What I was starting to look at next week. So this week we'll do 1 day of notes. We're going to do Friday notes. And then next week, I guess I didn't get that far.
Mr. Martha, when we win this game this week, we'll probably leave Wednesday.
I know. And I'm thinking about a quiz will probably be that next week, probably that Tuesday. So yeah, it'll work out just fine, right? But yeah, that's kind of what I'm looking at. I don't have it written down in stone yet, but it's looking like you will end new material next Monday, okay? And you wouldn't have a quiz until the following Tuesday. That makes sense? Because I figured that there's going to be some delay with football going on, okay? But I'll keep you up to date. I'm still working on that. So you don't have a quiz next week at all right? Not this week, not next week. But you do have a lab report, which we'll talk about here in a second. And that lab will be due on Monday. So you're going to do the lab tomorrow, but I'm going to give you through the weekend to write it because it's a little more involved than the previous labs you've had, okay? All right, so let's get things going. So we'll do like we do like in previous labs. I'm going to just talk about the procedure first. We'll look at it. It's up on eBackpack. And then we'll look at the actual setup over here in a second. Okay. All right, so I'm going to go to eBackpack. There's eBackpack. Let me get out of here. I'm going to go to your class. Your class, chemistry, section 2. You only have one chemistry, so I select that. I'm going to go here to conductivity of solutions. Conductivity of solutions. Okay. A little slow loading there. There you go. Okay. I'll zoom in on this. Okay, so this is going to be the first Vernier lab we're doing. Vernier is an equipment manufacturer, and they make these little probes here. Okay. And these little probes, and when you do that, you can go ahead and do that. A lot of it I'll show up on the screen, okay? Hey, what's up? Can you relinquish your seat for foreseeable future?
Sure.
Do you mind sitting where Chris Malik sat? Chris, were you right behind Trent? Okay. Okay, so we got a lot of our boys back. Let's see, we got Emerson. Opperman. Green. Okay, so these labs, first of all, use this software and this hardware made by a company called Vernier, and you interface them with the PCs, and then we can collect a lot of data and analyze it, and that's what we'll be working with this time around. And these lab reports, you notice they look a little different. These are actually from a manual made by the company. Now, I've gone through and tweaked some things here and there because it works better, but basically this is the lab we're going to do. It's called Conductivity of Solutions, the Effect of Concentration. Now, do you remember we had just got done talking about these equations right here? Okay, that's what we're starting to work with right now. Those things are called the same thing you call what's inside a Gatorade. They're called what? Yeah, these are electrolytes right here. So when you drink Gatorade, the reason you're drinking Gatorade a lot of times is to replace these electrolytes that you lost during sweating and intense activity. The thing is, though, is that when these things are floating around in water, because they're aqueous, right? Aqueous means water. You have charges floating around in water. And do you know what we call charges that are in motion? Very common thing. Electricity. That's electricity when you have charges in motion, okay? So what we're going to do is we're going to measure how well solutions that have these ions or electrolytes, how well they conduct electricity, right? And think about it, that's why you need electrolytes, because your nervous system works on electricity, right? It works on ions flowing in and out of your nerves. Okay, so if you take an ionic compound and you dissolve it in water, it dissociates or separates, and the resulting ions will conduct electricity. So if you take solemn sodium chloride like table salt and you put it into water, the ions are released according to this equation. So you take solid NaCl, you put it into water, and you get sodium ions and you get chloride ions, and they're aqueous because they have that hydration sphere of water around them. Okay. So in this experiment, we're going to study how the effect of increasing concentration of ionic compounds is on conductivity. So what do you think is going to happen if I add more electrolytes? What's going to happen to conductivity? It should get more conductive, right? Because there's going to be more charge carriers. So that's kind of makes sense. That's what we predict. And we're going to measure this as we increase the concentration by adding concentrated NaCl drops. So over here, I'll show you again in a second. At each of your benches, you have these guys made up here, and they're specific concentration of salt solutions. This one's sodium chloride. There's some other ones here too. And so you're going to add those drops progressively, and we're going to measure that. We're going to do the same thing for 3 different solutions that all have the same concentration, 1 molar, which we're going to talk about what molar means in a second. But you guys know what a mole is, right? It's a counting number, right? So molarity is another way to count. And the only difference is this. If I have a pure substance like copper and I weigh it, I can tell how many I have by using molar mass or atomic mass, right? The difference is here is this just isn't purely NaCl. What else is in here? Water. So if I want to know how many NaCls I'm adding, I have to know how many NaCls there are per a certain amount of water. Follow me? Okay, so I got to know like it's so many pounds per orange. I got to know what that orange weighs. Well, here I got to know how many NaCls are in a drop or in a liter or in a whatever. So we'll get, that's actually the next lecture on Monday, but it's, for the most part right now, it's not too important. Basically, you can think of them as all being the same strength. And we're going to do NaCl. We're going to do this salt, AlCl3, aluminum chloride, and this salt, CaCl2, calcium chloride.
So if you were to like, you don't want to go down so like to a minuscule measure,
Mhm.
could you just like find how many of the NaCl were in like a gallon? And
Yep.
then
Exactly.
proportionate?
And exactly, that's the way we do it. We actually do it per liter.
Okay.
Molarity is moles per liter.
All right.
And so we'll be working with, we'll have to convert milliliters to liters a lot and stuff. But we won't have to do those calculations in this lab, but it's just important to know that molarity is a way of counting, just like moles is. Okay, okay, and then what we're going to do is measure conductivity in a unit called, okay, no giggles, microsiemens, okay? It's not spelled the same way, right? It's different. But microsiemens per centimeter. And basically what it is Siemens is a company, it's an engineering company, and they must have come up with this kind of measurement. And it's per centimeter, meaning how much electricity goes through a centimeter of that liquid. Because if I had to go through a meter of that liquid, it wouldn't conduct as well. Does that make sense? You know, it's a longer distance. So it's based on how far the conduction is going through the liquid, okay? All right, so we'll look at all this stuff, but you're basically going to have a beaker filled with initially just water, and then you're going to add the drops to the solution and mix it up, and then you're going to put it up into this probe. And this probe will be on a ring stand with a utility clamp, and this thing will put an electrical signal or electrical charge into the water or into the solution, and it has 2 probes on it. One sends out an electrical signal, one gets the electrical signal. And they're not in physical contact with each other. There's like a little window here, and I'll show you that when we get close up on that thing. So when it's just sitting there like it is right now, the electricity has to go through the air to get to the other side to be sensed, and the air is not very conductive. Okay? But when I put it into the liquid, now those 2 things are connected by the liquid, and the electricity can flow through the liquid. And you'll see it when I bring it up close here in a minute. So as far as equipment goes, most of the stuff you are familiar with, like you've dealt with, well, I don't know if you've dealt with tissues yet, but you know what tissues are. You got a stirring glass rod, you made some of those. You've got some solutions that we're going to test. We got a beaker, we got a graduated cylinder. Wash bottle is like a little squirt bottle, we'll look at that. You should know what a utility clamp and a ring stand is. These things are kind of new to you. You're going to use a PC, you're going to use a computer interface. We're using these really small ones. Logger Pro is the software, and we're going to use a probe that can measure conductivity. Okay. Now, tomorrow when you come in to do this, chances are you're going to start to ask questions, and almost every answer is going to be, read your procedure. Okay, because this procedure is very, very well written. It tells you step by step. Follow it step by step, because if you make some mistakes, you can get really behind. All right, so you put your goggles on, and first it says your experiment setup should look like figure 1. So you should have your ring stand with your utility clamp holding the conductivity probe. Okay. You're going to make sure that the setting on this probe is correct. I'll show you it. There's a little toggle switch on there that you switch. I'll show you it in a second. Next, it tells you to prepare the computer by opening up this file from that folder. So you're going to do a file, open, go to this folder, open up that file, and basically what it does is it brings up a nice labeled graph, and it's all prepared for you. You're going to measure out 70 milliliters of water. Do we remember how to measure in graduated cylinders? Bottom of the meniscus, right? So here's our graduated cylinder, and let's say that's the 70 ml. We want to get the liquid so it's the bottom of the meniscus is touching that. That's how those things are made and calibrated. So again, when you do that, make sure that you put it on flat surface and you get down eye to eye. And just be careful. I'll show you when I show you the close-ups here in a second. There's 2 numbering scales on this. One goes from the bottom to the top, it goes up. The other goes from the bottom to the top, it goes down. That one is made for pouring out. This one, we want to measure how much we're going to put into it. So we're going to measure so it goes 10, 20, 30, 40, 50, 60, 70, not 70 down here, because that's really only 30. Okay, so you're going to get your water into there, and then you're going to get one of the dropper bottles. This tells you to start with NaCl. Now, over at these benches here, hey Matt. Thank you, sir. Now, over here at each of these benches, there's only 3 dropper bottles. There's one for NaCl, one for AlCl3, one for CaCl2. So let's say I'm the group working on this side here, and group over there, they grab the NaCl first. Well, I don't have to just sit there and wait. I can go start with one of these. But keep track of what you do in what order so you can label your graph. Get what I'm saying? The order that you do them is not important. Keeping track of which is what's most important. Okay. Yep.
Are you doing the same for all?
Do like a whole procedure for the first one, and then you can come back and repeat. And then you can come back and repeat. Yep.